Article 409 of the 2005 National Electrical Code, NEC, covers industrial control equipment for use in ordinary locations. It is important to note that this article was not included in the draft copy of the 2005 NEC because it was a new addition to the final version of the code. Article 409 provides requirements for the installation and use of industrial control equipment in ordinary locations. This equipment includes devices such as motor controllers, contactors, relays, and timers. The article covers general requirements, wiring methods, overcurrent protection, short-circuit current withstand, grounding, enclosures, and marking. The requirement for short-circuit current withstand in Article 409 is vital because it helps to ensure that industrial control equipment can withstand the high levels of current that can occur during a short circuit, which prevents fires and other hazards. Several interesting aspects of Article 409 are worth highlighting. Firstly, there is a new requirement for short-circuit current withstand testing of industrial control equipment. Secondly, there's a new requirement for using ground fault protection devices on such equipment. Thirdly, the article introduces a new requirement for marking industrial control equipment with its short-circuit current rating. Fourthly, there is a new requirement for the installation of industrial control equipment in a way that provides access for maintenance and servicing. These new requirements are important because they improve the safety of industrial control equipment installations. Now let's delve deeper into each of these key areas. First, general requirements as they apply to Article 409. These requirements establish the foundational rules for all industrial control equipment installations. This includes proper listing and labeling of equipment, ensuring it is suitable for its intended use, and adhering to manufacturer's instructions. The NEC mandates that all equipment be approved, meaning it has been evaluated by a recognized testing laboratory and found to comply with safety standards. Proper labeling is essential as it provides crucial information about the equipment's ratings such as voltage, current, and horsepower, as well as its intended environment. Using equipment in accordance with the manufacturer's instructions is paramount for safe and reliable operation. These instructions outline specific installation procedures, operating parameters, and maintenance requirements. Second, wiring methods. Article 409 specifies acceptable wiring methods for connecting industrial control equipment. These methods must comply with Chapter 3 of the NEC, which covers wiring methods and materials. Common wiring methods used in industrial control applications include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and cable trays. The choice of wiring method depends on factors such as the environment, the type of conductors used, and the need for mechanical protection. Proper sizing of conductors is critical to prevent overheating and voltage drop. The NEC provides tables for determining the appropriate conductor size based on the ampacity of the circuit and the ambient temperature. Third, overcurrent protection. Overcurrent protection is essential to protect industrial control equipment from damage caused by excessive current. Article 409 requires that overcurrent protective devices such as fuses and circuit breakers be provided for all control circuits. The size of the overcurrent protection device must be coordinated with the ampacity of the circuit conductors and the rating of the equipment being protected. The NEC provides specific rules for overcurrent protection of motor circuits, which are commonly used in industrial control applications. These rules take into account the motor's starting current, running current, and overload protection requirements. Fourth, short-circuit current withstand. The short-circuit current withstand rating, or SCCR, of industrial control equipment is the maximum short-circuit current that the equipment can safely withstand without causing a fire or other hazard. Article 409 requires that all industrial control equipment have a SCCR that is equal to or greater than the available short-circuit current at the point of installation. Determining the available short-circuit current requires a short-circuit study, which is typically performed by a qualified electrical engineer. The study calculates the maximum fault current that could flow at a given point in the electrical system. Equipment with a lower SCCR than the available short-circuit current must be protected by current-limiting devices such as fuses or circuit breakers. Fifth, grounding. Grounding is essential for personnel safety and to provide a low impedance path for fault currents. Article 409 requires that all exposed metal parts of industrial control equipment be grounded. Grounding is achieved by connecting the equipment to the building's grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The size of the grounding conductor must be based on the size of the circuit conductors. 6. Enclosures. Enclosures are used to protect industrial control equipment from environmental factors such as dust, moisture, and corrosive agents. Article 409 requires that enclosures be suitable for the environment in which they are installed. The NEC provides different enclosure types, each designed to provide a specific level of protection. For example, an M4 enclosure is designed to be watertight and dust-tight, while an M7 enclosure is designed to be explosion-proof. The choice of enclosure depends on the specific environmental conditions present at the installation site. 7th, marking. Proper marking of industrial control equipment is essential for identification and safety. Article 409 requires that all equipment be marked with its voltage rating, current rating, horsepower rating, SCCR, and other relevant information. The marking must be durable and readily visible. Equipment that is not properly marked may be rejected by the inspector. The new requirement for short-circuit current withstand testing of industrial control equipment ensures that the equipment can safely withstand the high levels of current that can occur during a short circuit. This testing is performed by a recognized testing laboratory in accordance with UL Standard 508A, the standard for industrial control panels. The testing involves subjecting the equipment to a series of short-circuit tests at different current levels. The equipment must be able to withstand the tests without causing a fire or other hazard. The new requirement for the use of ground fault protection devices on industrial control equipment helps to protect personnel from electric shock. Ground fault protection devices detect ground faults, which are unintentional electrical connections between a circuit conductor and ground. When a ground fault is detected, the device quickly trips the circuit, interrupting the flow of current and preventing electric shock. Ground fault protection is typically required for circuits that supply equipment in wet or damp locations. The new requirement for the marking of industrial control equipment with its short-circuit current rating makes it easier for installers and inspectors to verify that the equipment is properly protected. The SCCR marking provides clear indication of the equipment's ability to withstand short-circuit currents. This information is essential for ensuring that the equipment is installed in accordance with the NEC. The new requirement for the installation of industrial control equipment in a manner that provides access for maintenance and servicing ensures that the equipment can be easily inspected and repaired. This is important for maintaining the equipment's reliability and preventing downtime. Access must be provided to all components that may require maintenance or replacement, such as fuses, circuit breakers, and control modules. In summary, Article 409 of the NEC provides important requirements for the installation and use of industrial control equipment in ordinary locations. These requirements are designed to improve the safety and reliability of industrial control systems. By understanding and complying with these requirements, electrical professionals can help to prevent fires, electric shock, and other hazards. To further clarify the short-circuit current withstand requirements, let's consider a practical example. Imagine an industrial control panel installed in a factory. The available short-circuit current at the point of installation is determined to be 20,000 amps or 20.0 kiloamps. According to Article 409, all components within the control panel must have a SCCR of at least 20,000 amps. If a particular component, such as a motor starter, has a SCCR of only 10,000 amps, it cannot be used in this application unless it is protected by a current limiting device, such as a fuse or circuit breaker, that can reduce the let-through current to a value below 10,000 amps. The selection of the appropriate current limiting device requires careful coordination to ensure that it provides adequate protection without nuisance tripping. Another important aspect of Article 409 is the proper selection and installation of overcurrent protection devices. Overcurrent protection devices are designed to protect equipment and conductors from damage caused by overloads and short circuits. The NEC provides specific rules for sizing overcurrent protection devices based on the ampacity of the conductors and the characteristics of the equipment being protected. For example, the overcurrent protection for a motor circuit must be sized to allow for the motor's starting current, which can be several times the motor's full load current. The NEC also provides rules for the protection of control transformer circuits. Control transformers are used to provide low-voltage power for control circuits. The overcurrent protection for a control transformer must be sized to protect the transformer from overload and short circuit. In addition to overcurrent protection, ground fault protection is also an important safety measure for industrial control equipment. Ground fault protection devices are designed to detect ground faults, which are unintentional electrical connections between a circuit conductor and ground. When a ground fault is detected, the device quickly trips the circuit, interrupting the flow of current and preventing electric shock. Ground fault protection is typically required for circuits that supply equipment in wet or damp locations, as well as for circuits that supply certain types of equipment, such as electric heaters. The proper installation of grounding conductors is also essential for safety. Grounding conductors provide a low impedance path for fault currents, which helps to prevent electric shock and equipment damage. The NEC provides specific rules for the sizing and installation of grounding conductors. All exposed metal parts of industrial control equipment must be grounded, including enclosures, conduit, and cable trays. The grounding conductor must be connected to the building's grounding electrode system. Article 409 also addresses the issue of arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when there is a short circuit or other electrical fault. Arc flash can produce intense heat, blinding light, and a pressure wave that can cause serious injury or death. The NEC requires that employers perform an arc flash hazard assessment to determine the potential arc flash hazards in their facilities. The assessment must identify the potential arc flash boundaries and the required personal protective equipment, or PPE, for employees working within those boundaries. Employers must also provide arc flash training for their employees. In addition to the requirements of Article 409, there are other codes and standards that may apply to industrial control equipment installations. These include the National Fire Protection Association, or NFPA, 70E standard for electrical safety in the workplace, and the Occupational Safety and Health Administration, or OSHA, regulations for electrical safety. It is important for electrical professionals to be familiar with all applicable codes and standards to ensure that industrial control equipment installations are safe and compliant. Furthermore, understanding the specific requirements for different types of industrial control equipment is crucial. For example, motor control centers, or MCCs, are large assemblies of motor starters, circuit breakers, and other control devices. MCC have specific requirements for construction, wiring, and overcurrent protection. Programmable logic controllers, or PLCs, are used to automate industrial processes. PLC have specific requirements for wiring, grounding, and communication. Variable frequency drives, or VFDs, are used to control the speed of motors. VFD have specific requirements for wiring, grounding, and harmonic mitigation. The proper selection and installation of industrial control equipment requires a thorough understanding of the NEC, as well as other applicable codes and standards. It also requires a knowledge of the specific requirements for different types of equipment. By following these guidelines, electrical professionals can help to ensure that industrial control equipment installations are safe, reliable, and compliant. Let's consider some additional practical examples to further illustrate the application of Article 409. Suppose an industrial facility is expanding its production line and needs to install a new motor control panel. The electrical engineer designing the installation must first determine the available short-circuit current at the proposed location of the panel. This typically involves performing a short-circuit study which takes into account the utility's power supply, the impedance of the transformers and conductors, and the characteristics of other equipment connected to the electrical system. Once the available short-circuit current is determined, the engineer must select components for the panel that have a SCCR equal to or greater than the available short circuit current. This includes motor starters, circuit breakers, fuses, and other control devices. If any of the components have a SCCR lower than the available short circuit current, they must be protected by current limiting devices. The engineer must also ensure that the panel is properly grounded and that all exposed metal parts are connected to the building's grounding electrode system. The grounding conductor must be sized in accordance with the NEC. The panel must be installed in an enclosure that is suitable for the environment. If the panel is located in a wet or damp location, the enclosure must be watertight. The panel must be marked with its voltage rating, current rating, SCCR, and other relevant information. Another example might involve troubleshooting an existing industrial control system. Suppose a motor is tripping its circuit breaker frequently. An electrician investigating the problem should first check the motor's overload protection. The overload protection is designed to protect the motor from damage caused by excessive current. If the overload protection is set too low, it may trip the circuit breaker unnecessarily. The electrician should also check the motor's insulation resistance. Low insulation resistance can indicate that the motor windings are damaged. If the motor windings are damaged, the motor may draw excessive current and trip the circuit breaker. The electrician should also check the wiring connections to the motor. Loose or corroded connections can cause voltage drop and excessive current. If the electrician is unable to identify the cause of the problem, they may need to perform a more detailed analysis of the motor control system. This may involve using a multimeter to measure voltages and currents, and an oscilloscope to analyze waveforms. By following a systematic troubleshooting procedure, the electrician can identify and correct the problem. In conclusion, Article 409 of the NEC is a comprehensive set of requirements for the installation and use of industrial control equipment. These requirements are designed to improve the safety and reliability of industrial control systems. Electrical professionals must be familiar with these requirements to ensure that industrial control equipment installations are safe, compliant, and efficient. Understanding these regulations is key to avoiding hazards and ensuring the longevity and efficient operation of industrial control systems.